Hi guys, my name is Putra and my student ID is 2022810872. Introduction, application of differentiation. Application of differentiation are varied not only in mathematics but also in real life. Differentiations are vastly used across fields like science, engineering, physics, etc. What is differentiation? Differentiation is a method of finding the derivatives of a function. Differentiation is a process in maths where we find the instantaneous rate of change in function based on one of its variables. The most common example is the rate of change of displacement with respect to time called velocity. That's all from me. Thank you guys.
My name is MOHAMMAD Amin ROSLAN. My metric number is 2022852924. In mathematics, differential calculus is used to find the rate of change of a quantity with respect to other. In case of finding a function is increasing or decreasing functions in a graph, to find the maximum and minimum value of a curve, and the last one is to find the approximate value of small change in the quantity. Real-life application of differential calculus are calculation of profit and loss with respect to business using graphs, calculation of the rate of change of the temperature, calculation of speed or distance covered such as miles per hour, kilometers per hour, and etc., and to derive many physics equations.
My name is AIMAN RUSMI. My student ID is 2022-892958. And the definition of related rates is applied problems involve finding a rate at which a quantity charges by relating that quantity to other quantities whose rate of change are known. The rate of change is usually with respect to time. Chain rule or implicit differentiation is often used. Steps to solve related rates problems. The first step is to draw the diagram and label the dimensions. Number 2 is extract the information and find the formula that relates to the question. Number 3, differentiate the formula using implicit differentiation with respect of time equals to 1. And the last step is to solve the differentiation and find the rate of change stated. Thank you.
A straw is used to drink milkshake from a cylindrical cup. The cup's diameter is 8 cm. If the volume is decreasing at a rate 2 cm³ per second, find the rate at which level of milkshake is decreasing.
First of all, we will need to write down all the important information that we can find from the text, which from this question, we know that dV over dt is negative 2 cm³ per second. Why negative 2? Because it is stated in the question that the volume is decreasing, so we expected that the value will be negative. And then r is which we got by dividing the diameter into 2. We know that the diameter is 8 and we will be needing the radius. So to get the radius, we just have to divide the diameter, which is 8, into half. And that's how we get the value of the radius for cm. And in this question, we are going to find out the value of dH over dt. So, to solve this question, we have to know the formula of the cylinder volume, which is V equals to pi r square h. V represents volume, r is radius, and h is height. We already know the value of r, so we'll just have to replace the value of r to 4. So, 4 square is 16, and you will get 16 pi h. We can start differentiating the remaining variables, and you are supposed to get dV over dt equals to 16 pi dH over dt. And then you can replace dV over dt into negative 2, which the value that we got from the statement. Hence, change the positions onto the appropriate places. The last step is to simplify the value of dH over dt, and the result will be negative 1 over 8 pi centimeter per second.
Suppose that a manufacturing company wants to package its product in a closed can in the shape of a right circular cylinder. The merchandising department has determined that the volume of the can should be 16 cm³. Question A. Show that the total surface area can be expressed as S equals to 2 pi r square plus 32 over r.
Question B. Calculate the minimum surface area that can be produced.
Question 2A. Okay, from the question, we know that V equals to 16 cm cube, right? Okay, then volume is equals to pi r squared times height. Then we insert the value we have, which is V equals to 16. So we insert 16 into the equation. 16 equals to pi r squared times height. Then, as we know, we can transfer the pi r squared into 16. So when it's transferred, it will be h equals to 16 over pi r squared. Okay. S, or as surface area, is equal to side plus base. So S equals to 2 pi r times height plus 2 pi r squared. So from the we have done that, we have known that h equals to 16 pi equals to h equals to 16 over pi r squared. So we insert the value of h into the equation. 2 pi r times 16 over pi r squared plus 2 pi r squared. And then we expand it, so it is now equal to S equals to 32 over pi r squared plus 2 pi r squared. Now we just change the position of it, so it will be the same as the question. So now it is equal to S equals to 2 pi r squared plus 32 over r. That's all for me. Thank you.
For question 2b, we'll be starting off with a equal to 2 pi r squared plus 32 over r. And we bring the r to the top, and it's a equal to 2 pi r squared plus 32 r by the power of -1. And we get the first derivative, which is dA over dr equal to 4 pi r minus 32 over r squared. And then we equal it to 0. So it's 0 equal to 4 pi r like minus 32 over r squared. And then we just simplify it. 4 pi r equal to 32 over r squared. And then it's r cube equal to 8 over pi. And then we get r equal to cube root of 8 over pi. And then we continue to get the second derivative. So it's 64 r cubed plus 4 pi. And then we insert the value of r into the second derivative. So we get 64 over, in brackets, cube root of 8 over pi by the power of 3. And then plus 4 pi. We get the answer of it, 8 pi plus 4 pi. And then it's 12 pi because it's positive. So it is the correct minimum answer. So we go back to the original formula, which is a equal to 2 pi r squared plus 32 over r. We insert the value of r that we got from the first derivative, which is cube root of 8 over pi. So it's 2 pi r squared plus 32 over square cube root of 8 over pi. And we get the answer of 35.1502 centimeters square.
Based on the video, we can conclude that differentiation can be applied to find the change of rate of the volume and the minimum or maximum value of area.